to start with geometry textbook, the green one, and looks to me like what last time we left, we stopped off at. I got to get this set up. Okay, so looks like we left off with area of triangles and trapezoids, and we did rhombuses and kites. All right. We talked about those, the two diagonals there. Let's move over here to this thing. We worked on this page here, where we did the finding the measurements of the area of a kite. And then we did something like this, but I think we eliminated that. Let's move on to the next section. I think we've had plenty of practice. I think we started talking about this section right here. We got to example 2, number 4, I believe. So I'm going to hit, what I'm going to do is I'm going to do 4 and 7, and then move on to the next section, okay? So I'm going to get my paper ready, and I'm going to page 593. And we're going to do number 4, which you see the answer already, and the number 7. And we're going to try and find out how to calculate the area of a trapezoid and the area of a rhombus. Okay. I'm going to get my papers ready, so give me just a second. So whatever I write down, just turn it in when you can. We're on page 593. And we're doing the area of trapezoid. All right, and then over here to the left, we'll do the, zoom in on that. Then we'll do the area of a, what did I say, rhombus? Okay. All right, so over here we're going to draw this number 4 and then number 7. I'm going to put my name at the top. All right. So we've got a trapezoid that looks like this. 2 bases with 2 90-degree angles here. So that's going to be base 1, and that's base 2, and that's going to be my height. Base 1 is 9 meters. Base 2 is 15 meters. Height is 20 meters. So the formula is area equals 1/2 base 1, base 2, and height. Base 1 plus base 2 times height. Area equals 1/2, 9 plus 15 times 20 divided by 2. All right. So you could do 20 times 1/2 and get 10. 9 plus 15 is 24. So that's 240 meters squared. Let's check our answer from the book to make sure that's right. And yeah, that's right. So I'm going to leave that just like that. Let me turn that brightness down so I can see this a little better. Okay, number 7. Number 7 is a rhombus. So the rhombus looks like this. Okay. We have a diagonal that's 14 inches and a side length that's 25 inches. All right. And so in this case, we need to find the area of the rhombus. All right, let's go back and look at the formula. Okay, so for the area of a rhombus, you have D1 and D2, just like this. So it looks similar here. So the area of a rhombus has 1/2 of D1 times D2. Well, in this case, we don't have a D, we have a D1, but no D2. And you need to go back to look at, also they give you this side length here, which is 25 inches. So I'm going to pause just a second and kind of gather my thoughts before I start. All right, here's the properties of rhombuses here. It says if a quadrilateral is a rhombus, then it is a parallelogram. ABCD is a parallelogram. That means these sides are parallel. These sides are parallel. And if you'll notice, all these have tick marks on each side. So that means on this rhombus here, every side is 25 inches. So we can go ahead and write that out. Now, the one thing we don't have is a base and a height because we don't have a right angle here. So let's see what we can do with this. We're fixing to find a right angle. So you see that right there? All right, the diagonals form perpendiculars, right? That's what that means. So if a parallelogram is a rhombus, then its diagonals are perpendicular. All right, so that means AC is perpendicular to BD, okay? So and that means right here, if I were to draw like this, that means that these guys are right angles to each other, okay? Well, this length here across is 14 inches. Now this length right here, is it 14 inches? Well, let's double check. Now, if you'll notice, it's got a few more things here. We've got angle 1 is equal to angle 2, angle 3 is equal to angle 4. So these angles are equal, these angles are equal, these angles are equal, and these angles are equal. Well, that means these two, these two, these two, and these two are all equal, like to each other. So it doesn't say that 1 is equal to 5, but it does say that 1 is equal to 2, okay? And so, I'm sorry, let me rewrite that. So these two angles are equal, 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 just like that. So we have perpendiculars here. So we've got a base, but we don't have a height here, okay? How are we gonna find that height? Okay, so, all right, what you can do is come back here and use Pythagorean theorem. All right, and so if, okay, all right, now let me pause just a minute, just hold on just a sec, recording again. So according to this, since these two angles are equal, that means this length from here to here should be the same length as this from here to here. So if these two are equal, then each one of those should be 7 inches, okay? So in other words, I'm going to focus in only on this triangle right here. I'm going to shade it in and redraw it, okay? So we've got a triangle that looks like this. It's 25 on one side, 7 here, and I don't know that. Now how is this going to help me? I'm going to find the height, all right? So we're going to have the base, and we're going to have the height, okay? And then you can, if you have the base and the height, you can also find the diagonal, and the diagonal, double this length here, multiply them together and divide by 2 using this formula right here, all right? This is the formula I want to use for number 7, but I can't use this because I don't know this height here. So we're going to find that out by using Pythagorean theorem. All right, and so we're going to write, obviously the longest length is 25, 7 squared, b squared. All right, so what happens here? Let me pull this back so you can see what your note should look like. So far your note should look like this, okay? And you're going to have 49, b squared, and 625, all right? So 625 minus 49. Let me see if I can do this real quick. Okay, so all right, let's do second mode clear every time. So 625 divided by 49, that gives me 12.76. All right, so I'm gonna write down 12.76, but I don't need b squared, I need b. So I need to square root both sides. So the square root of 12.76 is, let's see what that is, second square root, second answer, and I should get 3.57. All right, let me pull that back so you can see what it looks like. All right, so the square root of 12.76 is 3.57. All right, so that means that this length right here is 3.57. And that means that this length right here is 3.57. So I'm going to draw an arrow at it. And then that means we have to double it. So first off, our first diagonal was 14. We knew that already. Our second diagonal is going to be 2 times 3.57, because you're going to have 3.57 twice. All right? And half of 14 is 7. And times 2 times 3.57. All right, so that's going to be 14 times 3.57, or let's see if I can zoom this in again. 14 times 3.57. I should get right at 50. See that? All right, so the area is 50 inches squared. Okay, so number 7's answer, let's go back and look at that. This is chapter 9 that we're in. Okay. 9-1 we were still on. We're going to go to 9-2 today. Okay. Number 7. Okay. So something's up with that last problem. Go ahead and write down what you see here, but something is really wrong here. I must have done something totally wrong. I got to double check something. And I'll go back and do that in just a minute. So I'm making all sorts of mistakes this morning. All right, so I'm going to go back and rework my problem. There's something up here because my book is not giving me the same answer that I'm getting here. All right. Yeah. Okay, so let me take a second and see where my error is here. I'm going to pause right there. So this is the first half of your problem. All right, all sides are equal. Okay, now one thing you could do, if you look at this on rhombuses, since you know all sides are equal here, and this diagonal goes here, and this it looks like to me you would definitely be able to find the area of one triangle easily, and then just multiply it by 4 to get the area of the whole thing. Let's see what happens when I do that. If because something is up with this number, I must have miscalculated here. All right. So if you got the base, which is 7 here, remember base is 7, and you had this height, which we just found out was 3.57. I'll tell you what, let me double check that to make sure that's right. It sounds right. I want to see. So 25 squared minus 49. All right, I get. Oh, I see what I did wrong. Okay, so, and y'all probably saw the same thing. So I'm getting, I'm supposed to get 576 right here. I made a mistake right here. This is it, 576. And the square root of 576 is not 3.57. What is that? All right, the square root of 576 is 24, okay? So 24 is my base. All right, so I made a mistake there, oopsie. Okay, now what does that mean? That means this right here is 24 from here to here. Now double that is 48. All right, so let's go back and recalculate this. So we've got 7 times 2 times 3, 7 times 2 times 24. All right, let's double check this. So I'm getting 7 times 2 times 24. I get 336. And that's what the book gives me here. So I think I'm good now. I must have really messed up right there. All right, so the answer was 336. All right. So my bad, oops. Okay, so we got the area of a trapezoid and the area of a rhombus. We went over the properties of a rhombus there just to kind of reiterate some things. Now let's go work on the section 9-2. I'm not going to worry about all these problems here because we just don't have the time to go over those. Now, I may go back and do a little, show you how to do a project like this, where you can find how to calculate the number for pi. How in the world do they come up with pi? What is 3.14? We can go over that maybe in the next day or so, but that'll be something interesting to try. But we're going to do 9-2, okay? So let's go over here to our notes. I'm on page 600. All right, so can't see what I'm doing here because this light is not right in here. Okay, so it looks to me like I can go ahead and start page 600, 9-2 section. And let's do, we're going to develop the formulas for circles and regular polygons. So I'm going to put formulas, circles, and / polygons. All right, so just jot this down. We're gonna fill in some notes here on your paper. So your paper should look like this. Okay, so we got our 2 problems there. And now we're going to fill in the blank down here with 9-2. And all we're going to cover is the main boxes here, the examples, and we'll do 1 practice problem from each example on this section here. So we'll do problem number 2, problem number 5, problem number 6, and then move on. All right. So we're going to do the formula for the circumference and area of a circle. All right. So let's see what this looks like. All right. So I'm going to write down the formula for the circumference and the area of a circle. So right here, we're going to write circumference is C equals, you can get 2 different formulas. You can do 2 pi r, or you can get C equals pi d, okay? So in other words, the circumference around a circle, we'll draw the arrow like this. We have a starting point, just like a snake eating its own tail. This is the length of the snake, if the snake was in a big circle like that, okay? All right, so that's called circumference. And what is r? R would be this radius. What is d? D would be this diameter, okay? So that's how you find the length of this. Like if a snake was circled up around itself like that, you could find out how long the snake actually was by just taking a picture of it and finding the radius out from the center out and multiplying it by 2 and then multiplying it by pi. Or you can take the diameter from here to here and estimate how long the snake is by multiplying it by 3.14. Okay. All right. So let's go over and look at area. The area of a circle. I'll go over here and write area. And A equals pi r squared, just like that. So you use the same radius. You multiply it by itself and then multiply it by pi to get the area. The area would be the shaded part in here, counted in squares. So if you counted little tiny squares inside here, that's how many, that's what the area would be. Okay, let's look and see what we've got. We're finding the measurement of circles. And so we're going to find the area of circle P in terms of pi. And that means the area here is going to have a pi in it. And so we're going to draw a circle. So here's an example. All right, so we're going to use an example. We're going to start off with a circle. Okay, and the circle has a diameter of 16. And it's called circle P because the center dot is located on point P. So circle P's circumference would be pi d. So it's going to be pi times, I'm sorry, we're getting the area, my bad. I'll tell you what, let's get the circumference and the area of the circle. So the circumference would be pi d, which would be that. So in terms of pi, my circumference would be 16 centimeters, so this would be 16 pi centimeters. Well, if I want an area, I would get area equals pi r squared, and the radius is half of the diameter, so that means your radius is 8, and we're going to have 64 pi centimeters squared. That's how you calculate those two values. So the distance around the circle is the circumference. That's how long this is. And then the number of squares inside the circle is 64 pi. Okay. All right, so let's move on to the next example. Now we've already figured out the circumference of that circle. So my notes look like this. Let's go ahead and make sure your notes look similar to mine. All right, let me see if I can darken this up here, just clear it up a little bit. Okay, so this is what your notes should look like. You can freeze the screen and then write it down as you see it, and then turn that in. Now I'm going to go over here. I've got plenty of space left and plenty of time to work on that. So let's fill in the gaps here, all right? So we just did the circumference of a circle and the area of a circle. An example, here's your formulas. Now I'm going to come over here to the right on page 601, and we're going to look at this says, I'm just going to read this out. I'm not going to draw this out. This says that if you were to find the radius of circle X, where you have the circumference already found given to you, then you just basically work backwards. All right. So let's go and look at that real quick. So we're going to find the radius of a circle called X. So come over to the right. I'll tell you what. Let's keep all of our circle notes straight down in a straight line here to make them nice and neat. All right. So let's go circle X. Okay, so draw me a circle with an X in the middle, a dot there for the radius. This says the circumference is 24 pi, and then inches. Notice it's not inches squared, okay? So what do we want to find? We want to find this radius right there, that little question mark right there. I'm going to zoom in on it so you can see what I'm doing, okay? So we want to find this question mark, that's the radius of that circle. So how do I do that? I'll go back over here to where C is, and I plug in the formula that has radius in it. So I'm going to put 2 pi r, just like that over here. So I'm going to put 2 pi r for instead of circumference. And over here we have 24 pi. And if you'll notice, you can cancel your pi's by dividing both sides by pi. And you could divide both sides by 2. And we get 12 from a radius. That's going to be in inches, okay? So that's pretty straightforward. Now let's move over to the next section here where it says, we need to, let's find the circumference of circle S. I'm just showing you how to read this. So the circumference of circle S in which area equals 9x squared pi centimeters squared. So that's the area, and it's measured in squares. So I'm not going to worry about what the area looks like. What I am going to worry about is the circumference. Okay, so let's see what we need. Okay, my computer froze there for a second. I don't know what's going on. So let's get back to what we were doing. So we were finding the circumference of circle S. So I'm going to start off with a circle called S, just like that. So we have a circle P, a circle X, and a circle S, okay? So we're going to find the circumference of the circle. That's going to be like if it were a snake coiled around itself, eating its own tail like that, you see? All right, that's how long the snake is. So if you stretched it out, that would be what the circumference is. So I want to find the circumference, and they give me the area. So I'm gonna come back and find the circumference in a minute, but we're gonna use the area to help us. So first off, we need to put 9x squared pi centimeters squared, just like that. And now let's come over here and write down in where it says A, that's area. We're going to put the formula pi r squared there, okay? So we're going to try and see what we can find given all that information there. So area equals pi r squared, and then they told me that the area was this. So now, just like on the last problem, you can see how I've got pi's on both sides. Well, you need to go ahead and think that you can cancel those out. And now it looks to me like we're going to find the radius of this circle in terms of x. That's what that's going to turn out to be. So if you rewrite this, r squared equals 9x squared, that means we need to find the radius. That in order to do that, you have to square root this square. All right. So the square root of 9 is 3, and the square root of x squared is x. So my radius for my circle is going to be 3x. So if you come over here, circle S is going to have a radius of 3x. So that means in order to find the circumference, you're going to have to use the formula for circumference that has, right here, that has the radius in it, not the diameter. So radius was 3x, and I'm just going to put a 3x right there, okay? So come up here and put C equals 2 pi r, all right? And so C equals 2 times pi, and then you put your 3x in the place of r. So now I'm going to rework this, and 2 times 3 is 6, pi is pi, x is x, leave it just like that, and that's going to be my answer in terms of centimeters, because it was centimeters squared earlier, okay? So my final answer is 6 pi x, just like that, or 6x pi, whichever way you want to write it, okay? Now, I'm going to pull back. Let's see what our sheet should look like. All right, so you should have the area of a trapezoid, the area of a rhombus, the formulas for circles. You got circumference here, area here, several ways to find those circumferences and areas. Now we're going to come over here and do the next section. which is going to be example 2, okay? All right, example 2 says, now this is dealing with a musical instrument, okay? So I'm going to pull this. This lady over here is playing the drums, okay? So you can see how her bass drum has a circumference, and then the area would be the square centimeters or square inches of the drum head itself, okay? So how big is the circle around? That would be the circumference. And how much area does my drum head cover? Well, that's what you use 2 different formulas to find those. All right, so let's go back and look at the problem. It says a drum kit contains 3 drums, and in this case we've got 1, 2, 3 drums with diameters of 10 inches, 12 inches, and 14 inches, okay? So we're going to find the area of the top of each drum. So the area is going to be the drum head. So the top of each drum is where she would hit it with her drumstick. So, so 10 inches, 12 inches, 14 inches, and small area, medium area, large area, okay? So this number should be small, medium, large, just like that. So if you'll notice, the formulas for the area of a circle, since the drum is a circular figure, you're going to come over here and let's fill in our blanks. Let's find example 2. Okay, this is on page 601, section 9-2. Okay, all right, and so now we're going to find 3 different areas. So you have a circle that has a 10-inch diameter, 12-inch diameter, and 14-inch diameter. So in this case right here, we'll draw a circle that's a 10. We'll draw a circle that's a 12. And we'll draw a circle that's a 14. So the same area formula is going to work for all 3. The only problem is we need to change the radius size. Well, if this is the diameter, then the radius should be 5. If this is the diameter, the radius here should be 6. If this is the diameter, the radius here should be 7. You just cut the diameters in half, and that gives you the radius. So we're going to recalculate this. Area equals pi times 5 squared. Area equals pi times 6 squared. And area equals pi times 7 squared, all right? So we get area equals 25 pi for this first circle. Area equals 36 pi for the next circle. And area equals 49 pi for the last circle, okay? Now, these are all in terms of inches, okay? So I'm going to put inches squared there, inches squared there, inches squared there, and leave it just like that. I'm not going to actually answer the problem because I don't want to clutter up my notes. All right. So let's go look at one last thing before we leave. The area of a regular polygon. All right, this may be the last thing that we cover. So the area of a regular polygon has an apothem. Okay, now if you look at this, how do you pronounce this word? A-P-O-T-H-E-M. I'm going to go to Google. Let's see if I can pull this up and look up the dictionary version of the word A-P-O-T-H-E-M. So this is the way you would pronounce it. All right, let me turn that up.
Apothem.
Apothem, okay. So if you look at this, let me pull this up. the upside down E means you do like an sound or a apathem. This is the stressed syllable, apathem. Okay, now let's go. The area of a regular polygon with apathem, A and perimeter P is A equals 1/2 AP. So the apathem is basically, if you look at it like a circle, it's kind of like the radius. It goes from the center of your shape down. You'll notice how this makes a right angle right there. So it's kind of like you're almost like half of your height. Like if you were to look at this shape, it'd be like half of your height basically. And so perimeter, what's perimeter? Well, it's just like, okay, what if a snake was able to coil up into a big, what size shape is this? 1, 2, 3, 4, 5, 6, 7. That's a heptagon. So what if a snake was able to curl up into a heptagon like this? Would the length of the snake be different? No, it would just be, because the snake's as long as it's going to be, it's just shaped into a different form instead of a circle this time. So the perimeter and the circumference would be kind of the same. So the area of the regular polygon with apathem A and perimeter P is area equals 1/2 apathem times perimeter. So I'm going to write that down. Area of polygon. All right, so you're going to have area equals 1/2 times apathem times P, just like that, okay? Very simple. And I'm just going to write P is perimeter. Little a is apathem. Okay. All right. So now we're going to spend some more time on that tomorrow. So I'm going to stop right here and let's call it a day on this. This is our notes for today, and we're going to finish tomorrow with example 3. Cannot stretch that out far enough. Okay. Okay. I wonder if I can turn. No. All right. Let's see if this will help. If I can put it like this. Adjust this. Okay, now that's your notes. I don't know if you can read the bottom down there. It's going to be really hard to read that. That's exactly what you need to have for your notes for today. Okay. All right. We'll see you tomorrow.